In the last video, we started discussing a couple of different sorting algorithms. In this video, we're going to start the implementation of BubbleSort, which is one of the easier methods of sorting an array with JavaScript. I'm inside my code editor. Let's open up our sorting directory and open up the index.js file inside there. In this file, you'll notice a couple of different empty functions. And so in each of these functions, we're going to implement a different sorting algorithm. The idea here is that we are being given an argument ARR, which is short for array, of course. So this is going to be an array of numbers, and it's going to be up to us to somehow sort this array and then eventually return it. So I would expect after implementing all of our sorting algorithm stuff, so we're going to implement BubbleSort, and then after we do that, we're going to return the sorted array at the bottom. So don't forget the return statement. Let's also not forget to start up our tests. So over at the terminal, I'll start my tests up with just sorting test.js -- watch. All right, we've got 3 tests failing, 1 for each algorithm that we're going to implement. So let's take a look at a diagram that's going to help us understand exactly how BubbleSort works. On the right-hand side, I've got some pseudocode for the algorithm. And then on the left-hand side, I've got an imaginary list of numbers right here. We're going to walk through this sorting algorithm, and for every step through, we're going to modify this list of numbers right here to make it a little bit more obvious exactly how the sorting works. Notice how the first 2 statements here, the first 2 pieces of our BubbleSort algorithm are 2 nested for loops. These nested for loops are iterating over the same set of records. And remember, one of the earlier rules that we had mentioned around time complexity, or the worst case time complexity, is that any time that you see nested for loops iterating over the same collection of data, that's an automatic red flag that we might have n-squared runtime complexity. And like we just mentioned, BubbleSort at its worst case is n-squared complexity. So we can see that here in action. All right, let's walk through this thing. We're going to start off first with an outer for loop that is going to iterate over our whole collection of records. So everything from I all the way up to the array length. So this outer for loop essentially goes from 0, 1, 2, 3, 4, 5. Then for every step along the way, we're going to iterate from j equals 0 to array length minus I. So for every step of the outer for loop, the inner loop is going to have a shrinking window of elements that we're going to step through. So the very first time that this for loop runs right here, so the first time through the outer for loop, we're going to iterate over all these items from the inner for loop. Then the second time, the inner for loop is only going to iterate through this set. And then the next time, only through this set, and so on. If I had to give you a 1-sentence description of BubbleSort, I would tell you that its purpose is to find the largest element in the array and drag it over to the far right-hand side. And so that's exactly why we get this shrinking window. The first time that we run through our array with BubbleSort, we're going to find the largest record in the array, which in this case is 97, and we're going to move it all the way over to the right-hand side as quickly as possible. And so that's why you end up with this shrinking window. When we move the largest element all the way over to the right, we know that the element at the very end has now been sorted into the correct location. So we no longer need to look at this element right here. We only need to consider the window of elements before it. So let's take a look at exactly how BubbleSort makes that happen. So we're going to iterate from the first element to array length minus I. At every step along the way, we're going to look at the current element that we're looking at. So the j iterator right here, we're going to imagine starts off at 0, and we're going to ask the question if the next element in the array is greater or less. If the next element is less than the current one, then we're going to swap these two. So in this case, the current element is greater than the next one, so we're going to swap 10 and negative 30. So notice how the larger value here naturally starts to get dragged on over to the right. Then j increments by 1, and we now ask if the element at index 1 is greater than the element to the right. In this case, no, it's not. It's less than. 10 is less than 97, so we do absolutely nothing. J moves forward again, so j would now be equal to 2, and we move on to our element 97. We again ask if the element at j is greater than the next one. In this case, yes, it is. So we're going to swap 0 and 97. J moves forward again, and we compare 97 with 5. Again, 97 is really large, and so we swap them again. And so now 97 is at the very end of our array. So now that it's at 97, now that 97 is at the very end of our array, and it is the largest number, we can assume that 97 is at its properly sorted location, because we just went through, found the greatest number, and moved it all the way to the end. So now this inner loop is going to terminate. We'll go back out to the outer loop. I increments to 1. We then start out the inner loop again. And now we're going to only iterate from 0 to array length minus 1. And so essentially, we no longer are going to be considering this element at all. Now all the inner loop logic is going to run again. And in this case, the 10 is going to be dragged all the way over to the right-hand side. And so we end up with something like this. Now, right at this point in time, the array is sorted, but we do not have any logic inside of our for loops right here to actually say, hey, we're sorted, so don't do any more work. Even if the array gets sorted early, the for loops are always going to run all the way to continuation with the default way that BubbleSort is implemented. Now, that's not necessarily the biggest thing or the biggest deal in the world. Remember, BubbleSort is a less efficient algorithm. If we wanted to, we certainly could put in some type of check to look and see if the array was completely sorted. But for the usual implementation of BubbleSort, we don't really worry about something like that. All right, so that's the general idea behind BubbleSort. At this point, I would like you to take a shot at the implementation of BubbleSort. So all of these sorting algorithms we're going to go over are pretty challenging in nature. So I recommend you give it a little bit of a try, but if it's too challenging, don't sweat it. Just check out the solution and make sure you understand how the solution works. So with that in mind, let's take a break right now and continue with a solution in the next video.